Hello and welcome back. This time what I want to do is just quickly solve that last challenge. Hopefully you were able to do it yourself and figure that out, but now I want to just show you how I would have done that. I'm starting here with the sketch that just prints the potentiometer, read the potentiometer's value, which is on pin A0, and prints it to the computer user. And what I want to add to it is, and use its position, oops, no apostrophe, to change the rate of blinking of an LED on pin 5. Always good to write notes to yourself at the top of your sketch saying what it is actually doing. So if we have an LED on pin 5, then we'll have to do pin mode 5. It's going to be an output. We don't have to do any other things in the setup. And then down here in the loop, we don't need to change any of this. This can all stay intact as it is, but I'll just add some code down here, blink the LED based on the pot position. So how do we actually achieve it? Well, we write the same kind of blinking code we're used to writing, sorry. We say digital write 5 high, a delay, and digital write 5 low, a delay. The only thing we're going to be doing that's different from before is changing how long the delay is. This is the whole thing we had to do, is just change the delay, make it match the potentiometer's position. How do we do it? Well, we just need to put a number in there, and the number is potVal. We put that variable right in there, like that. Then it will turn on for however long potVal is in milliseconds, and it will turn off for however long potVal is in milliseconds. And it so happens, because we've seen those values before, this actually makes sense. potVal at the high end is 1023, so that would be a 1.023 second delay, which is like a reasonable number. And at the low end would be 0. That is not a reasonable delay. It's going to be blinking. The effect of delay 0 is like practically no effect at all, so it'll be blinking really, really, really fast. And as you turn the potentiometer, it should be changing. That will update every time the loop runs. It'll do that update. So line 25 will do the updating, and then both of those delays will be affected by whatever line 25 decided potVal should be based on the analog read. Also, you will notice when you run this code that your serial prints are not coming at a steady pace. The serial prints are coming faster when the lights are blinking faster and slower when the lights are blinking slower. Why would that be? Well, when you write this line 29 and you're telling the Arduino do this thing on line 29, it will, but only when it gets to line 29 in the code. So if you have a very long delay here, let's say it turns on, waits a second, turns off, waits a second. You had to do all that waiting, 1 second, then 1 more second, then gets back to the top of the loop, then do all this stuff, and then finally it's going to get back to line 29. So it could take 2 seconds between getting serial feedback. Of course, if the delay is quicker, then the blinking is going to happen faster and the serial feedback is going to be happening faster. So it's important to remember that everything in your loop is going to be slowed down by big delays. And so generally when we write code, we're not going to put big delays in the loop because it is big trouble. Next, we're going to learn a fun new input that will open new worlds of possibility.